All right, today's lecture we're going to go over question 17 first from the daily math practice from lecture 13 and proofs of parallelograms. I'm not going to go into too much detail with the proofs because we got a lot of practice tomorrow. I just want to give you some general basic facts about parallelograms. Okay, so let's go ahead and get started with question 17. I already got drawn out here. Alright, I kind of got lost in everything. Everything kind of hit me so fast. What I'm going to do, guys, is we got to figure out x, but the problem is, we got an x out here, and we have no clue what's going on here, and we got an x here and an x here in that angle. There clearly is just not enough information to see it right off the bat, and me trying to explain it in a way that it happens really quickly, it doesn't. So that's why I kind of saved this problem for the video. Now, what I'm doing is I've drawn two parallel lines, and I want to be able to find x, okay? Because if we can find x, eventually we'll be able to find the angle measures. I got too many unknowns in too many places, and I got to try to set up some kind of equation. Now, what I'm going to do is, sometimes you just have to step back and look at. I want to extend this line here, the transversal. Now, I made it a transversal. If I use vertical angles on this, all right, let me change colors again here. I know that this angle here is vertical to this angle, which means that this must also be 6x minus 7. Now, if we recall back, okay, we talked about the alternate exterior angle theorem. If I go across this so-called transversal side here, all right, remember I just jump over the transversal, exterior meaning outside the parallel lines. So I'm going to jump over the transversal and get outside the parallel lines. This is also 6x minus 7. Okay. Now, I'm going to extend this end up a little bit. Now, here's a curveball that I didn't see happen. And why they did this on the practice, maybe they wanted you to figure it out using all those different theorems in one problem. If this angle measure here is 103 minus x, okay, that's this right here. If I use the alternate interior angle theorem, I'll be able to figure out where it is at down here. The reason I'm doing that is I got too many unknowns. I'm trying to figure out how to set up this equation. Now, so what I'm going to do is, with this angle being inside here, I'm going to jump over the transversal. Okay, that's the transversal side. Jump over it. I'm interior, so I'm going to stay there inside the parallel lines and bring that angle here. Now, it don't look like much, but here's another thing that I wanted to show you, and this is kind of like the key factor, the game changer that lets us be able to solve this problem. This angle that's in pink here, we know nothing about it. We're not even given an unknown. It's just plain out missing. And I have not enough information to figure it out. Because I was wanting to take 6x minus 7 plus this angle and set it equal to 180. Well, I don't want two variables. I just want to find x. So what I'm going to do is I want to use, again, the alternate interior angle theorem and stay inside, jump over the transversal here, and then bring that angle down. I don't know what it is. I'm just going to put a mark. Now, I got everything going on right here. All right. If we think vertical angles now, this angle is vertical with that angle. So what's that mean? And that was the question that I had. I'm like, well, if these two angles are the same, what's going on with 6x minus 7 and all this? They are vertical angles. This guy is equal to 2x plus the 103 minus x. Now, looking at that, that looks like something that you can't solve, but when you write it out, it really is. Just take a look here. I got 6x minus 7. I'm going to set it equal to 2x plus the 103 minus x. Okay, 2x plus 103 minus x. Now, I can solve for x. It might take me a minute, but I can solve for it. So I'm going to go ahead and really fast forward this and really solve it quick. I'm just combining my like terms, something I know you've done in the past 4 years now. All right. So as I'm going through this, take the time. If you didn't get that part of how I came up with this equation, you need to really pause, rewind the video, and keep watching it. Sometimes it takes a couple of times to actually get something down. I even have to watch a YouTube video a couple times to get what they're saying. So as I'm solving for x, I'm down to the wire now. I get x equals 22. All right. Guys, that was all the theorems we talked about to solve that problem. Now, you might be able to come up with something different. And there's always a different way, but I found that to be kind of the easiest way of solving this. I just had to see it for myself that this is vertical to all this. I'm trying to fix that line there. That was a hard thing to understand, but I wouldn't have known that if I wouldn't have drew these two vertical lines here, or vertical angles here. And then as soon as I saw that, it made a whole lot of sense. So, all right, let's talk about the basic facts of parallelograms real quick, and then we'll go over some of the proofs tomorrow in class. So, parallelograms. What do we know here? Well, parallelograms are four-sided figures. Okay, four-sided figures. The sum of the angles. All right, sum of angles equals 360. And you'll probably see that here in a minute. And diagonal, I'm trying to sound it out and spell it. Diagonal angles are congruent. Okay, they're equal in size. All right, so I want to draw a parallelogram. Obviously, parallelogram has two sets of parallel sides. That was one of the facts that I didn't write down. I just felt like these two things were more important to know because we're going to look at angle measures. All right, so I'm going to draw a parallelogram, or try to anyway. Okay. Now, the one thing too about parallelograms is that this side and this side are the same length, and they're parallel to each other. And this side are parallel to each other, and they are the same length. That's the beauty about parallelograms. Okay, they got two sets of parallel sides, and both sides are the same length. Now, we'll do some proofs tomorrow, but like I'm going to give you an example problem that I think would be beneficial to you. Let's say the question is find x and y. Okay, angle x and angle y. And what I'm going to do is I'm just going to draw this out like, I'm trying to think of a number here. Let's go 4y. Let's give this angle to be 52 degrees. And, gosh, I don't want it to be like, be able to work it out nicely. So let's say we have that. We got to find x and y. Okay, now I said something in the previous slide that said diagonal angles are congruent, meaning they're the same size. Now, let's look at the obvious. I got 4y. I got one angle measure. That's 52 degrees. So what I would do, guys, is basically just set up an equation. Well, 4y is congruent. It's equal to 52 degrees. I can solve for y. So that's a simple little one-step equation. And I believe that is 13. So y equals 13. That was pretty simple. Now, guys, these kind of problems, especially in geometry, they give you enough information to figure out a solution. There's always going to be enough information, no matter what kind of problem you have. Some problems they give you too much. All right? Diagonal angles are congruent. Well, I got 5x plus 38. Well, I don't know what this angle measure is. Well, how could I figure it out? Okay, now that's a good question. Here's the solution. This angle here, okay, if they're on the same parallel line or side, these two angles here are supplementary. I'm sorry. All right, meaning they both add up as 180 degrees. Well, what you just simply need to do is take 180 minus 52. You know, I'm going to long subtract here because some of you guys forgot how to do that stuff. This angle measure here is 128 degrees. So, there's the bell. I'll see you. Anyway, we have 128 and 152. These two angles are supplementary. These two angles are supplementary. That's how we figure out the missing angle measure here. So that needs to be equal to 128, okay, to set up my equation. Now I can just go ahead and simply solve here, okay. And guys, this is, thank you, ladies. Bye, Seidel. Some of these are just simple equations, guys. Stuff you've done before. I know I keep saying that. X equals 18, I believe. Make sure my math is right. 5 goes into 9 one time. Yeah, I'm good. So x equals 18 and y equals 13. Now, you'll get several of these tomorrow, and they're not going to be as simple as this. I just wanted you to get the basic facts and definitions down. All right? So, I will see you tomorrow.